Hello everybody, welcome back to another code review. In this video, we're going to be covering a game called Globs, which was originally submitted for the GMTK Jam, that's the Game Maker's Toolkit Jam, in 2024. And here's that original Jam page. There were 7,564 entries for GMTK Jam 2024, and this game placed number 89 overall. Now, my understanding is that this game has been further developed from the Jam version, and that's the version that we're going to be looking at today. So if you want to support the developers as we get into this, check out the links in the description below, but let's get right into the game and see what we're dealing with. And the developer, by the way, is 9sliced. All right, let's go right in and test out the game. All right, so we can press anywhere here. This brings us to an overworld map, which looks really good, actually. And I don't know what this button does. Oh, those are options. Okay, cool. And we got a menu hamburger button. Very nice. So this is the first level, I'm assuming. So I'll click on that. And the object of this game, as far as I can tell, is you need to extend these globs or these blocks such that they collect the stars. So first level, very easy. But then we get 2 globs. And the solution for this one is to extend this by clicking this handle up and then extend this over so that it pushes that other block. So that's the core concept of the game. I'm sure it gets a lot more complicated as the levels go on, but that's the general idea. So we're going to be taking a look at what's going on under the hood in this game. So we'll see if we can find anything interesting. Okay, the first thing that I want to do is I want to familiarize myself with how the levels are actually being constructed. So let's see if I can find the levels. We have a very nicely organized project as far as I can tell. So this is looking great. And I just went into scenes, levels. So we've got a level template here, which looks like it just has all the things that we need. It's got a goal, which is great. And we've got some blocks, background, props. Okay, so that looks like just tile map layers. That looks good. What are the errors we have in here? Okay, I think we can ignore these errors for now. Let's go ahead and look at where the world levels are. Okay, so here we've got levels zoomed. I don't know what that means, but level 100 test. Okay, level 110. Okay, this looks like our initial level. Now the question I have is, where is this level actually being loaded in the game logic? So this is very beautiful, by the way. I don't know if this is using an asset pack or if this is bespoke art, but it looks wonderful. It's very colorful. I love how clean the pixel art is. So the art looks amazing. And this is a very good use of scene inheritance here. So this extends what I'm assuming is the level. Oh, it's extending the... Okay, so we have a base level that is being extended by the level 100 template. And then all of those 100 levels are extending that template so that we have the background and the colors and all that good stuff. So ultimately level 110 has those things built in and then adds more decorations as needed. Now let's go ahead and right click on this and go to view owners and see if this level 110 is loaded anywhere, and it's not. So that tells me that the level configuration is not being done as part of an export variable or anything like that. All right, so we need to figure out how that level is actually being loaded. Let me just search scripts for level, and maybe we'll have a level manager or something in here. I'm not seeing a level manager, but we've got level data. So here's a level data. This is an auto load, it looks like. Let me just go to project settings. We'll go to the global section, and we have level data as an auto load here. So let's see what's going on in this level data. Okay, so we've got our level configuration. Okay, so we've got a level name, world 1, music, city, scene. Okay. And this levels is an array of objects. All right. So already what I'm noticing here is these could be replaced with resources. So when you have a dictionary like this, where all of the properties are the same and you're trying to come up with an array, we need a name property, we need a world property, we need a music property, we need a scene property. This is begging to be converted into a custom resource. So I might actually go ahead and do that, but let's just continue on with this train of thought and see what these levels look like. So we've got a scene to level data dictionary. This is a private method, and it looks like this create scene to level data is taking that levels array, and it is, oh, it's just creating a different map. It's creating a different dictionary where the scene is corresponding to the level data. And then we have increment level. So this is probably where this is happening. increment level. Okay, where is this being called? This actually does not change anything. It just changes the level number. So where's increment level being called? Increment level and change scene. Okay, end drag. So that's ending the drag of whatever block we're on. It's going to increment the level, get the current level, and change to scene with transition. Okay, so this is how the levels are actually being loaded. So the levels array here is specifying the order of the levels. And then anytime that increment and change scene is called, it will increment the level number, and then it will also orchestrate that scene transition into the next level. So that makes sense. Now I'm just going to make sure that this dot levels is not used anywhere else. So let me just find dot levels. And it looks like we are maybe using this in different places. Yeah, so level button is using that as well. I think this is going to be pretty much a drop-in replacement though. So let me show you what this would look like if you used a custom resource. So what I would probably do is I would probably create maybe inside of my, well, it doesn't really matter where I put this. Let's just go ahead and I'm just going to create a new folder in here called resources. And again, you know, it doesn't really matter what you do here. This is not necessarily me telling you that you should use a resources directory, but as long as the organization makes sense to you, then I think it'll be fine. In here, I'm going to create another new folder and I'm just going to call it level data, like so. Actually, that might be a problematic name because we already have something called level data. Let's call it a level config, and let's create a new script inside of here. And we're going to call this level config.gd. So let's open up that level config.gd. We're going to extend resource in here, and let's give it a class name as well. Class name level config. Okay, so let's go ahead and do this. So what are the things that we need? We need the name, the world, the music, and the scene. Okay, so I've gone ahead and wrote that level config resource, and I've basically just taken whatever properties we expect in the dictionary, and I've put them as export variables on this resource here. And the most notable thing here, I think, is that I am exporting an enum for the different music types so that we have an explicit selection of one of these things, and that enum is going to be stored as a string enum value. And I'm also constricting the world or restricting the world to be only in the range of 1 to 4 as an int. So that's just adding a little bit of guardrails on what we can input. The name can be anything and the scene can be anything though. And then if we want to create a level config, let's just go ahead and create a new resource here. And if I just search for level config, as long as I have a class name up here, in this case, it's class name level config, that's going to allow me to create a new instance of that resource through this editor window here. And let's just call this, I'll just call it 1-1. I'll just use the names as they exist. You could name it basically whatever you want as long as it's sensible to you, but I would do level config and then maybe just call it 1-1. And then if I go ahead and double click on that 1-1 to open it, we can see that we've got all of these things here. So in the scene, it needs to be level 110. So we'll do level 110.tscn. Name, this is 1-1. The music in this case is city. So we get a nice drop down selection there. And the world is 1. So I'm not going to do this for all of the levels here. I'm just going to go ahead and maybe create those levels for maybe the first 5 of the initial world, because it's going to take a while to translate all these over. Now, what you could do is you could write an editor script that you can run that would convert all these dictionary values into a resource and save that to the disk. I'm not going to go that deep into it, but let's just create a few of these here. So I'm actually in the process of creating a resource for this world selector, and I realized that world selector does not have a world value. And so if you have a value that's expected to be an integer, but you want to mark it as null or non-applicable, what you could do is I'm going to create an export range of maybe 0 to 4. In this case, we're starting with 1 as a valid value. So I would just set the world to 0 here, and that would indicate that there's no world associated with this. And then I need to go back and change all of these worlds to 1 by incrementing them. I think you maybe understand where this is going now. And so what I'm going to do here now is I'm just going to show you how I would set this up through the editor. This level data is loaded as an auto load, but is not attached to a scene. If I want to make this configurable, what I could do is I could create a scenes. I'm going to create an auto load directory in here. So folder auto load. And what I could do is create a new node in here. So let's do a new scene with a node type of node. Let's call this level data.tscn. Actually, these are snake case. So let's do level data.tscn. And in here, I'm going to go ahead and attach that script. In this case, I think it's res scripts autoload. Yeah. So now we've attached that. Now here's what I can do for the levels. I can do @export var. I'm going to call this levels new so I don't have to rename this because I want to preserve this, but I'll call this levels new and we're going to make this a type of array of level config. Actually, let's call it level configs. Yeah, that'll be a good one. So now that this is a scene, I can configure those level configs in here. So now I'm going to add just my 5 elements there. And I'm just going to go ahead and drag over 1, 1, 1, 2, 1, 3, 1, 4, and the world selector there. I'm going to rename this to levels old, and I'm going to see where this breaks. You know what? I actually am going to rename this to levels. So I might have to, yeah, let's just go ahead and rename this to levels, and I'm going to reset this. So I just want to preserve the naming so I don't have to do a bunch of refactoring here. Okay, so now we've basically replaced the levels array with this new levels for level configs instead. And let me just see where .world is being referenced because that changed from a string to an int in my implementation here. So let's see where .world is used. Okay, I actually don't see .world used anywhere. So let me now search for maybe this. Yeah, here we go. Anywhere where this world is being referenced, I'm just going to convert this to a string just to maintain the sort of backward compatibility. Okay, and actually these can't remain indexed either. So this actually needs to become level data.world because level data in here is going to be typed as a level config. So that should help me out a little bit. Get level data, we're going to return a level config out of here as well. Scene to level data is going to be a dictionary. Now I did upgrade this project from 4.3 to 4.4.1 stable. So I believe you can do typed dictionaries now. And I think this case would be a string level config like so. So that's a little bit of a nicer way of determining what your dictionaries are actually storing. So the key is a string and the value is a level configuration there. So if we create scene to level data, scene is level data.scene. I'm sure I'm breaking all kinds of things here, but basically since we changed it from a dictionary to a resource, we need to access the properties differently. We shouldn't be using the brackets here to do this. So I'm just going to make sure that that's all working well. Let's go ahead and now run this. And what I should see is basically everything should be the same. And we got a problem here. I forgot to type the return type of this as well. So this needs to return a dictionary of type string level config. And let's also type this here, levels array. This is going to be an array of level config, so we can type that as well. So now we should be able to get, yeah, now we've got some good stuff going on here. This is a packed scene, right? So instead of these scenes being string paths now, these are actually packed scenes. Let's just go ahead and do this. Let's do scene.resource path instead. So we'll just keep that create scene to level data. We'll keep that dictionary as a string key of the scene path. I hope that works. Let's see. Okay, press anywhere. We've got our world config, and I think it seems to be working. Oh, you know what? Actually, there's one other thing I need to do here, which is I need to change this auto load. So in the project settings for globals here, this level data, this needs to change. So project settings, globals, level data. I'm going to delete this and add that level data node now. So we go to auto load level data, add. I'm going to move this up to be the third option like it was before, and we close this. Now we're going to try this. Okay, now what's worrying me though is that it should have started breaking and it appears to still be working. So why is that not breaking here? Because remember, we've got our levels configured in an array here. So the 5th level should be the world selector. So really, I should only be able to go into the first 4 levels. So I wonder why it's not working. Let me try something here. I actually don't know how the levels are being loaded here. So I'm actually going to take a look at the remote scene tree. What do we got going on in the remote scene tree? What's actually happening here? We got world select. There's an Easter egg in here. What? There's an Easter egg called glob and glob face. Where is that? I want to find it. Well, anyway, I couldn't figure it out. So let's go ahead and go back to levels here. So I'm not going to be able to find that Easter egg, but it looks like we've got world select. And then in our scroll component, we've got world 1. So if I go to world 1 here, and I've got each of these individual levels here as nodes, so that makes sense. So level scene. All right. So that's a little bit of a problem, I think. Let me go into here. Let's see what's happening in this script. So this level button has an export variable for what scene it represents, so what level it should go to. What happens when I click into it? There is something weird happening here. I'm sure it's happening for a good reason, but when I see a regex inside of the process method, I think that's a big clue that there's something wrong here. There's so much to talk about with this project. This is actually a really, really fascinating project. So I'm not going to go into why this is happening here, but I just want to put a pin down on that and say there's something weird happening here, and I wish I had time to go into it and look at it more. You know what? Leave a comment. If you want me to do several episodes on the same project, if you want to see more of this project, I'm totally open to doing that. There's no reason that these videos have to be only a once look of 45 minutes and then done. If there's more to talk about, there's more to talk about. So leave a comment below if you're interested in seeing another video of this project, or just leave a comment telling me what's most fascinating so far. So we got start level here. Level data selected level name. So this is setting a property directly on the level data autoload, change to scene with transition. This is like an architectural problem. So you're storing the level scene inside of each of these level selector buttons, which again are these little nodes here, right? So you're storing a scene name in that, which is fine because you need to be able to look up the level data associated with that scene. What I would probably do actually is I would probably do this. And again, this is a little bit tangled, so I don't know if I'm actually going to get this working. But what I would do here is I would maybe do an export var level config like so, and then type a level config resource in there and then pass that in. And then when you want to change to that scene, on button pressed here, we got start level. This is really bad. I mean, I don't want to say it's really bad, but when you're changing the state of an autoload, which is a global node directly, you shouldn't do that. If you're going to access variables or set variables through an autoloaded node, I would much prefer to see personally that happens through methods, that happens through functions. So you should have your internals for your autoload, and then your functions should be the API, you can think of it, that any system in your game can interact with the autoload. This is fine, this change scene with transition here, but right here, we need some internal level data state to be set. So what I might even do is I might do this. I don't even know what the selected level name is being used for. So this is being used all over the place. Yeah. So this is making the code really hard to work with, is that we've got all of these variables being set all over the place. So I'm not even sure I'm going to be able to finish my level config refactor here. So here's what I would do. I'll just give you a broad sort of overview. In the level manager, so in these level buttons, I would add your level config here. So to go back to world 1 on this level, this first level here, this currently has a string path of level 110. I would change that. I would quick load 1.1, that resource I created, put that in there. So that's our level config. And then what I would do is I would go to the script here, and when I need to transition to a level, I would probably in my level data script here, which is that autoload, I would just create a function in here, maybe call it like transition to level, and I would accept the level config as an argument here. And then what I would do is let's just copy this scene transition autoload and put that in the level data here. And we need the level scene. So this level config dot scene there. And this probably expects a path, right? Yeah. So that expects a path. So we can just do dot scene dot resource path like so. And then we can set the internal values here. So current or level, or what is it called? Selected level name is equal to level config dot name. So this is actually named a little bit misleadingly. This says selected level name, but it's actually pointing to the level scene path. So I'd actually rename this to selected level scene path and be really explicit. But let's just go ahead and set that to level config dot scene dot resource path. So you set any internals inside of the method that you're making publicly accessible. And then, so this whole line here, these two lines anyway, these can be changed to level data dot transition to level, and I can pass in that level config here now. And the nice thing about passing around a level config rather than a string is that the level config as a resource contains all the data you need. So it has a reference to the scene, it has a reference to the name, it knows what music is playing. Anything related to the level can all be stored in here. And then you can just pass that level config object around instead of having pieces and bits of levels scattered throughout your code, right? This makes it a lot easier to, I think, manage the chunk of data that represents a level. So let's see if my change there, that transition to level, worked. So in level.gd, where I put in transition to level, let me just see if this works. And I'm just going to print in here so I know for sure that this code is being called. So it should be the case that only level 1 works. And I've got transitioning in here. So level 1 works because I assigned that level config to it, but it should break if I select anything else. Yeah, because I did not assign the level config. Okay, cool. I don't think I'm going to be able to finish the refactor that would be necessary for doing that level config, but generally speaking, that's what I would do. So inside of the level data, I would replace all of this with level config files. And again, you can write an editor tool that will take this existing data and write it to a resource. That's totally doable. And then I would, instead of passing the scene path around, I would pass around the level config object or that level config resource. And then I would also avoid setting the internal variables for this autoload anywhere else in script. If you need to do something, it should always be done through a function call to the level data object, or the level data autoload. And then that function can be responsible for updating any of the internal state as necessary. And the reason why that's good to do is because then you can change the underlying implementation of the level data. So like I could have much more easily replaced the internals of the data structure in here with a level config if everything was accessing the level data functionality through a set of publicly accessible methods. Because then all it's a matter of doing is just changing the implementation in this class, in this script, and nothing else. But the moment that you start reaching into the internal data of a globally auto-loaded node, and you start doing that in several places across the code, that's when you end up with a tangled mess where you're setting all kinds of data in different places under different situations, and it's just not clear when data is being set or why data is being set. So you get the semantic meaning as well from having functions. Like the functions can tell you exactly what's happening when a script elsewhere is calling this function on level data. And the other benefit too is that that's kind of a layer of abstraction. The functions serve as a layer of abstraction between the internal state of the level data and the state of the rest of the game, right? That's just my opinions on that. Let's go ahead and take a look. The notes as part of the submission for this project mentioned that we've got block.gd, which is 1,000 lines of code. And if I'm not mistaken, I think block is probably the things that you drag, right? So let's go to scenes block. Yeah, so this is the thing that you drag. So let's take a look at how these blocks are actually working here. So this is going to be a monster script here, and I'm not actually sure that I'm going to be able to go into or understand all of it. But what I'm mostly interested in is like where the handles are happening. So create direction indicator. So we have a direction indicator. Okay, there we go. So we have a direction indicator. So that's being created somehow. So in create direction indicators, that's being created, and that's called internally as soon as ready is available. Okay. And how does it know? Oh, left extendable. Okay, so that means that at the block level, then we probably have export variables here. Selection, visuals, extendable directions, up extendable. Okay, yeah, so we've got a bunch of configurations here. So if we're extendable up, so I'm actually just going to mess with this base block scene. It's probably going to break some things, but if I make it up extendable, that should, oh, I can't see it. That should add the up extended. So let me do this instead. Let me go to level 110. And in here, let's take a look at what this block is doing. So let's see. Block 2. It should be only right extendable. So extendable directions, right extendable. There we go. Okay, so these are all the configurations that determine how the block is extendable. That's fine. Let's go back to the script and let's look, see if we can pick out where the block is actually being moved. Okay, so in here we've got physics process. Oh goodness, we have gravity enabled. Oh goodness, okay. I did not encounter any gravity blocks, but it looks like we can potentially have blocks that can fall, which is very interesting. There is something weird happening here. And again, I don't have really the ability to understand everything that's going on in this script, but I'm just going to give you my opinion here. There's a physics process which happens every physics process frame. And we're doing this check here. I'm not entirely sure what this same axis or is moving is doing, but what I'm noticing in here is that we've got a tween list here that is appending a gravity tween, and then it's, oh, I see, okay. So I know what's happening. So this gravity tween is being created, is falling is set to true, and then it's also going to set is falling to false after the tween is done. Okay, so basically the first frame where this is true, it's going to go ahead and create a tween that drops the block down and then sets that to false. Okay, so that's fine, I think. I thought that maybe these tweens were being created maybe every frame, but it doesn't look like that because it's gated behind this is falling here. This may, and again, I don't know exactly what's going on here, but this may be a good candidate for a state machine. If you've got certain stuff that needs to happen only when a certain state is true, rather than putting it to a big bunch of if checks in here, you could maybe split up the behavior into multiple different states, but I'll just mention that. Let's keep going on. Okay, so this looks promising. We've got this function here called onClickAreaDragging, and that looks like the code that's responsible for making the block move when you drag it. Okay, we've got a control node acting as a click area in here. So this click area, oh, it's got a dragging signal. Okay, interesting. So the way that these developers are checking if we're dragging a block is that there's this click area which gets dragged. Okay, that's a clever way of doing that. I don't really see any obvious problems with that. The benefit of using a control node for your click area is that, yeah, you can work with mouse events very easily. So that's a very clever way of doing the click and drag detection. And then we've got the extend block function in here. So this extend block, this is where the meat of the functionality is, it looks like. So let's see if I can parse through this and just understand what's going on here. So we're checking can extend. That looks like it's just restricting it to the extend range. So I'm looking at this code. I don't know what variation is. Is that something that can be set through the inspector? So there's this get variation function here. This is getting the difference in the drag from its initial starting point. That's my best guess anyway. Again, without doing a deeper dive into this, I'm not really going to see, but there's a lot to talk about here. So back to extend block. So that variation is playing a crucial role in determining how the block extends. So we've got a check movements function. What is this doing? So to be honest with you, this code is very, very hard to understand as a new developer to this project. There's a lot of numbers floating around. There's a lot of conditionals. And I know that this is a very difficult project, generally speaking. But this block extension, yeah, it's not the easiest to understand. But I think I understand the goal, generally speaking, because you have blocks that can move other blocks, right? And you need to make sure that a move is valid. So if you're up against, like in here, a static block, you don't want to be moving. But if you're against a block that can be moved, you want to move it. You know what I might do here? And this is just me thinking if there's a simpler way of doing this kind of movement check where you need to move a bunch of blocks at once. Maybe I'll just write out some pseudocode here and talk about that, because to be honest, I just don't know what's really going on in this extend block function. I mean, I understand the goal of it is to extend the block in the direction that you're dragging, but it looks like there's a bunch of sort of like weird checks happening. Movements is empty. I think there's a simpler way to handle this, and I could be wrong. This game, I'm sure there's a lot of complexity involved, and of course there's a gravity feature. I haven't even seen that in the game yet, so take this with a grain of salt, but I'm just going to maybe go over how I'm thinking about how I would handle extending blocks, including managing other blocks or moving other blocks. So here's what I would do. I would do something like this. I would say func, maybe have like a move block, and I would design this so that it moves one block or one grid at a time. So I would take a reference to a block like so, and then I would take like a vector2 for movement direction. And so what's going to happen here is, oh, I typed that wrong, vector2. So before move block has happened, what you'd want to do is do your block movement validation. So you want to do like can move in direction, vector2, and we could make this more of like a cardinal direction so it's more clear, and just return a bool. I'm just going to return true, but you would do your sort of check that block is capable of moving in given direction. So then this move block here would take a reference of the block that we want to move and the movement direction we want to go in. Maybe we could pass in a block here as well. So what I would do is I would say if not can move in direction, block movement direction, then we can just return out of there. Otherwise, what I would do is this block is currently I think it's an area 2D. I would actually make this probably a character body 2D. I know that sounds a little bit counterintuitive, but a character body 2D gives us the ability to, I believe, test movement. Let's just assume that these are character body 2D. So I'm just going to change this type actually to character body 2D. So if we can't move in the direction because of its directional constraints, that's fine. Otherwise, what I would do is I would probably do this. I would say block. Oh, wait, I just realized that there is a test move here. So we can actually use that. So never mind. We don't need to use that move and slide. We can do test move. So we can do test move from, and we can use the global transform of the block. So we'll do block.global transform. And then the motion that we want to use can just be this motion here. So we'll do var motion is equal to movement direction times tile size. Let's just say const tile size is equal to 16. So there's our motion in there. So we're going to move it by an entire tile. Actually, this doesn't look like what we need either because we need data about the collisions that are returned. So I actually probably want to do move and collide here. So I know we're going back and forth, but this is kind of a hard problem, but I would probably do block, move, and collide. And this actually takes a motion here. So we can pass in the motion like that. And we want to do test only. We can do test only to true here. So that's going to return the collision data for us. So we'll set test only to true. And if we see that the body does not move, but the would-be collision information is given. So that should be good. So we're going to get the collision data from this. It's equal to block.move and collide. So what that's going to do is that's going to try to move the block given the motion. So we're moving it over one tile. And this is a virtual detection, right? Because we have test only. So it's not actually going to move anything, but it is going to return the collision data. Inside of that collision data, we are going to get, so we get a kinematic collision 2D. We can get the collider, which would correspond to another block if it collided with a block, right? So we could do this. Var collider is equal to collision data dot get collider. And you'd have to check collider not null first, I think, because this would probably be null if it doesn't return anything. Or maybe that get collider will be null, but you'd have to check if it's null. But let's assume that the collider, let's just say if collider is character body 2D, remember this character body 2D is a stand-in for the block. Then what we're going to do again is we're going to do this. We're going to call move block with that collider and in the movement direction. So again, this is just pseudocode, but what we're doing is we want to check if all of these move blocks are successful. So let's return a Boolean here, and let's return false there, and then let's return move block there, and we'll return true by default. You'd also probably want to do this. If collider is tile map, return false. Okay, so then what you would do is I would actually call this maybe check move block or something. And then let's do func try move block. And let's take the block character body 2D and then the movement direction vector 2. And then in here, this needs to be check move block. So in try move block, what we would do is we would say if check move block, the block and the movement direction, then what we would do in here is apply all movements. Now, the thing about this is that this is only returning a Boolean. So again, this is pseudocode, but I'm just going to stop there and I'm going to explain what's going on as well as some of the problems with this. So firstly, we want to do a can move in direction check to make sure that we can actually move it in the direction that we're trying to move it. In other words, when we're dragging the handle, we only want it to be able to move in the direction that the drag is going. If you try to move it up and you can't drag it up, then this should return false, right? So this try move block is going to try to move the block, but first it needs to check if it can move in the direction, and we're going to check move block. Now this is a recursive function. So basically what's happening in here is it is check, oh, this is a duplicate. Oops, this is a duplicate check. Sorry, pseudocode, but Anyway, so this is checking if it can't move in a direction, then it's going to return false. But this is recursive. So we're going to get the motion, which is the movement direction, times the tile size. So we're going to move the block an entire tile virtually. If that block collides with another character body 2D, which is going to be another block, then we are going to have a reference to that collider. It's going to check, okay, if that collider is a character body 2D, we're going to see if we can move that one the same distance in the same direction. So that's going to chain them, right? So we've moved one block, we're going to try to move the second block, and then since it's recursive, that block might also move other blocks, right? And so on and so forth. So it's going to recurse and check for every character body 2D that every block is going to collide with as a result of the motion, right? At least that's the idea behind the pseudocode. There may be an error in here, I don't know, it's just pseudocode, right? But that's the idea. And if the collider is a tile map, we're just going to return false because we don't want to phase through the tiles, right? Okay, but assuming that all of those checks are valid, all those checks are true. So basically a character body 2D is going to be able to move as long as it's not colliding with a tile map. And that's going to shift all of the character body 2Ds over. So let's say that you collide with, you push one block and it pushes another block and you push another block. All of those movements, all those checks need to succeed and not collide with a tile map in order for this check move block to succeed as well. Now, what we do need though is after we do that check, we ideally want to have a list of all of the character body 2Ds that need to be moved. So there's two ways to do that. You could make this return an array of collisions. So maybe we'll do this. So instead of returning just a Boolean value, okay, so here's what we can do if we need a list of all the kinematic collisions, right? We could take this method here and we can pass in a result list. So let's do results, array, kinematic collision 2D. And I'm going to just go ahead and do this. Var results, array, kinematic collision 2D equals empty array. Let's go ahead and pass that results array in as the third argument there. And this is passed by reference. So that means we can modify this array here. And I'm just going to put this on a new line so we can see what's going on here. So we're going to still return a Boolean if it doesn't succeed or if it does succeed. But in this case, we need to pass in the results there. But if the collider is a character body 2D, we can do results.append collider as character body 2D. And actually, I did this type wrong. This should be a type of character body 2D, and this should be a type of character body 2D as well. So every time we collide with a character body 2D, we're going to add that to the results list. So inside of this if check move block, now we have, if this check succeeds, remember it's going to return true if it succeeds. Now we have all the character body 2Ds that we need to do. So what we can do in here is we could say for block in results, animate to position, and then we would pass in like the block and then the movement direction, or animate maybe in direction or something. And then if we have an animate in direction function with a block as a character body 2D, as well as the movement direction vector 2, then what you can do in here is you could apply tween to move block to desired position. I'm just going to rename this to collider block actually because there's an issue. So anyway, I'm not going to go too deep on this, but hopefully that makes sense. So as you can see, what we're going to be doing instead of whatever's going on inside of the block for extending the block. So if I look for extend block, so instead of doing whatever we're doing in here, we're just going to use recursion as well as the built-in physics system to detect the collisions. Now, I'm not sure that this would actually function as a replacement because again, it's really hard to see what the needs and requirements of this game are. But if I were to build this game from scratch, this is the approach that I would take first. Because what we can do, again, is we can just recursively check all the block collisions in advance in a virtual way without actually moving anything. And once we're sure that all the movements can be carried out without colliding with a tile map, then we can actually use that list of character body 2Ds and just animate them over, right? I'm fairly certain this code is not just going to work out of the box. I wrote this mostly just to kind of exemplify or illustrate how I would approach this problem if I was making this game from scratch. If you can leverage recursion and you can leverage the built-in physics system to detect when block moves are valid, then I think that that's going to maybe create a cleaner code base for you. But yeah, as it stands right now, this block script is very, very hard to understand. And if I was a new developer that was tasked with fixing a bug in here or adding new functionality to the blocks, I don't think that I would be able to do that with any sort of confidence. And it certainly would take a very long time to figure out what's actually going on here. Anyway, that's going to be it for this code review video. The unfortunate thing about these projects is that they're so good and there's so much going on that I wish I could talk about them all day, but we got to keep the videos a reasonable length here. Again, if you want me to do another video on this project, I'd be open to it. I kind of want to give everyone an opportunity to have their project featured, but sometimes there are these projects that just have so much going on that it would be awesome to just do more of a deep dive into them. So anyway, let me know what you think. Check out the Steam page for Globs. You can buy it right now. Definitely support the developer. Thank you to 9slice for submitting the project. It was super educational, super valuable for everyone to see. And leave a comment below what you liked most about this project, what you liked most about the code review. Did you learn anything? And if you want to submit your game for code review, you can check out the links in the description below. There's a Google form link you can use to submit your game. And then of course, check out my offerings as well. I've got Udemy courses available for sale. It's a great way to support me. It's a great way to learn how to build games in the Godot engine. Thanks again to everyone for watching, and thanks again to the developer, and I will see you in the next one. Thanks for watching this video. If you want to support my work, you can purchase one of my courses, you can purchase my game Gunforged on Steam, and you can sign up for my email list at firebelly.com. All the ways that you can support me are linked in the description below.